Programming Throwdown, episode 110, Security with Dotan Nahum. Take it away, Patrick.
Hey, everybody. We're here with 110th episode, which is pretty exciting. And we have a guest today. Oh, yeah, go ahead. You want to celebrate?
I was just saying, yeah.
So we're here with a guest today, Dotan, and you are CEO of Spectral. Why don't you go ahead and introduce yourself briefly, and then we'll get started.
Yep. So hi guys. So I'm Dotan, and by the way, 110 is binary, right?
Oh, there we go. That's right.
You didn't
How did
see
we miss that?
So I'm Dotan, CEO of Spectral. It's a cybersecurity company geared toward developers. I mean, we like to say that we create tools for developers with security as a side effect. So that's what our focus is.
Awesome. Well, I mean, I guess that's a lot to unpack. So I think everybody would agree security is very important, but maybe everyone doesn't understand what security is. So we were talking about this a little when we were during warm up. So if we talk about security, does that mean that you're developing antivirus for computers for developers, or does it mean something more?
Yeah, I mean, it's kind of all goes back to, I guess, evolution of our, I guess it is our domain, our world, which is kind of high tech or software world. Time really gets compact with all these revolutions. We have evolution and revolution. So I mean, if you go back to 2007, that was just before Facebook and just before iPhone, I guess. And if you go back to 2005, that was before the rise of Microsoft, I guess, the major rise of Microsoft as a .NET shop, which really made all the enterprise software come along. And then kind of 98, 2000, the first bubble. So all these stages, it's kind of a sprint to create technology, and the focus is on creating technology that is supposed to give developers productivity and supposed to make companies very productive and create a very nice portfolio of products. And almost always, I mean, maybe not intentionally, but almost always the security side of things was kind of left behind. you know I'm sure no one intended for it to be, but there's a lot of more velocity under creating a great product at the time, at each and every step of this, like in the first bubble, and then in 2005, and then into 2007, and so on, rather than okay, so let's create the technology and the product, and let's also make it kind of dependent on making great security be there for us. So almost every time, security came after the revolution, after the evolution. So we had from simple firewalls to intrusion detection, which is the large kind of systems that try their best to find anomalies in the area of 2000, to the smarter firewalls, and even today, those like this mini kind of firewalls of WAFs that you integrate as an SDK into your app. So it's kind of it comes in waves, technology, and then security comes in waves as well. And yeah, so the latest we're seeing right now in terms of the evolution of software is that, yeah, we know that software eats the world, but we are kind of feeling that it already ate the world. So you can do so much today that you couldn't have done, I mean, as little as 3 or 4 years ago, actually. You can take a Lambda and you can pick up a bunch of SaaS services and you're done. I mean, you built a product that used to be maybe 3, 4, 5 years ago, used to take much more energy to build. So in that sense, as a developer, you have so much more power and so many more paths to get to the same end goal that I'm not sure. I mean, I feel it for myself. I'm not sure the security world can even begin to realize, because they need. I mean, if we think about them as then they need to understand how to develop as well as developers in order to create great solutions for that developer that glues stuff together and invent stuff from existing parts.
Yeah, that makes a bunch of sense.
I didn't say, yeah, that covered. I mean, you went to the whole history of modern or last couple decades of computer software there. But I was going to say, so one of the interesting things I think before we get into the kind of specifics about what needs to be secured, this kind of thing you mentioned where people build a product first and then try to figure out security later. I guess that's an interesting balance where if you're building something until it's built, maybe it doesn't really need security, right? If it's just a thought in my head, I don't need security. If people are going to start using it, though, immediately you need to start having some amount of security. Do you have opinion on like what is the balance there? So if you don't know yet what you're doing and what may be your risks, when is the right time to start considering security, and what are some of the good, first things to start considering?
Yeah, so that's a great question. I mean, I think the balance is shifting towards really taking the time in development time, in design time, and think about security on the security model. So, this was kind of theoretical. Yeah, everyone should do threat modeling and everyone should do secure by design and so on. And frankly, you'll find these people who are extremely into security that are actually doing these things. But the thing is, it wasn't being done properly or by everyone as kind of a development workflow. When you come to develop a feature, then you have the design and you have maybe a POC, and you're supposed to have this small or maybe large threat modeling box, but no one actually does it, or most people kind of focus on the other areas of developing a new feature. So it is that way because we're used to taking a product and pushing it into you know your traditional server farm or your really secure and isolated cloud operation, whatever, and you're pretty sure that within this closed garden, even if you didn't do the proper threat modeling as a developer, then things will be okay. However, this kind of understanding is changing because it's no longer pushing to a server or to a kind of a closed garden environment. It's, taking your function and placing it somewhere. And now someone can ask a question, which is, I don't know, I don't have the answer. If I push a function to whatever, I don't want to name any service, but it's kind of any of the new hip cool services out there that really make you productive. If you push that function, did the other side do everything they need to do in terms of their traditional threat modeling to keep you safe? Are they obligated to do it? Do they have, let's say a WAF to identify SQL injections for you, maybe, or maybe to drop someone who's attacking your service and so on? I'm not sure, actually. So it kind of shifts the responsibility to the developer because you're building a function, you're dropping it on a whatever cloud provider, and your function is now live. uh, you know it's up to you, right?
Yeah. So I guess you were talking about deploying these functions and applications to public facing cloud. Or do you think that the same applies to internally deployed app like enterprise software that would just be used sort of within your corporate firewalls? I think you were sort of referring to this when you mentioned walled garden approaches.
Right. Right. So I believe like eventually the closed enterprises really adopt whatever is happening on the open, let's say on the open wild world. So, you know, maybe we need to give one realistic example. So let's say I'm working at kind of an Acme Corp, some kind of corporation, doesn't matter, and I'm a developer, and basically I have this service, small service to build, and I decide to build it on, I don't know, Heroku, or I don't know, Vercel. I do that. No one is stopping me. I can do it. And then I can plug it into my existing infrastructure inside the corporation. And I don't know if that would be something that is, okay. I mean, as a developer, I'm just, shipping software. But here's something that, an ability or a possibility that wasn't there 5 years ago. Heroku was there, but the culture of shipping things fast and being able to take things to the extreme, end to end, wasn't there. So here's one path that is now open, and now people can actually wake up tomorrow and figure out, scan their code, and look for external services that exist in the code base, and try to figure out how many are there that they know of and how many are there that they don't know of. And that's just SaaS services. Now you can take the same analogy and try to think about what kind of libraries do you use. And everyone remembers leftbed, right? When it was just suddenly pulled out of npm, breaking half the internet. That's kind of the new world that's happening in the last few years, that I'm not sure everyone are ready for.
So what would be an example of, like you mentioned, building a Heroku-based, application, deploying it and scanning for what services that you may not have realized. Do you have examples there of like what would be something that you may not intend to have exposed that got exposed?
Oh yeah, I mean, well, first there's this kind of the cyber world call it shadow IT, where people basically what they want to do is be more productive inside the organization. So it's kind of two sides of the coin. One is positive, one is negative. And the positive side is you have a team that thinks it can move quickly and adopts, unvetted software, so to speak, and then ships it to production, and that creates a bunch of IT assets. I don't know, services, SaaS services, whatever you can think of, that actually no one knows exists in production. On the other side, if from a cyber perspective, that is an unauthorized use of software, which is kind of giving it a kind of a warfare kind of name, like a shadow IT, like shadow ops. So this example. If you guys even check your stuff, then maybe you can find many examples of that. But it's kind of a productivity thing.
Yeah, I think so. Maybe just stepping back a bit, like it'd be really good to explain to folks like what are the different components of computer security, like what actually a firewall is, and how to protect against like what is a SQL injection? Like what are the kind of threats that you encounter, and how do those things work?
Oh yeah. So I think first of all, let's try to get the motives out there, right? So there's hackers and there's the good people and bad people, right? So to speak. So I guess developer builds software and they're trying their best to actually add value, and the hackers try to, I don't know, remove value or try to game the system and gain some profit really quickly. So basically, when I build, for example, when I build a function, I don't know, that takes a parameter from a URL from a website, and maybe it's a page number, traditional paging feature. Then I take this parameter and I inject it into an SQL query that I have on my backend, and my goal is to just give you page number 2. So that's my perspective as a developer. I see nothing, no harm done. I mean, I'm taking a value and dropping it inside a string which contains an SQL query. and I'm done. Like I push this feature, I go home, and that's it. But the other side of it is that when a hacker looks at it, then first of all, there's what is it for me? Like what's there to gain? So first of all, the company needs to be really attractive in terms of hacking anything, and there has to be some kind of trophy on the other side. So if I'm looking at something at some company as a hacker, and I realize they might have sensitive data because they're, I don't know, healthcare, whatever, then at least I have now the motive or incentive to actually try to figure out where can I hack into. So looking at this naive SQL thing that developer just built, so I'm looking at a parameter, and what I'm trying to do is take, instead of giving the parameter what it expects, which is a number, I'll try as a hacker to, try to inject some malicious SQL code. Maybe if I'm in for doing some damage, maybe I'll try some drop tables instead of a number. If I have reason to believe that the backend will actually give me the results as I wanted, then I'll try to inject an actual query into the number instead of a number. And what I'll hope for is for the developer not to actually be defensive, which means the developer forgot or didn't bother to actually sanitize the parameters and make sure that if the developer expects a number, there only should be a number there. So that is kind of the gist of SQL injection. So this is one kind of attack. So just a little bit about firewalls. So basically, a firewall is something that sits between a machine and the outside internet, or maybe internal internet, doesn't matter, the outside world. And what it tries to do is to monitor traffic and figure out which traffic is strange and which traffic is normal. So it used to be, it used to be very simple. It used to be basically looking at open ports and trying to block irregular ports on machines. That is like 20 years ago. And today it's a lot smarter. So today, a firewall is maybe not the correct name anymore, but it's a system that looks at anomalies in your traffic, and that is the acronym is WAF, which is Web Application Firewall. So many cloud providers have that, and you can actually flip a switch and have it as a feature. And basically, it looks at your traffic and it can recognize what is normal and what is not normal, and usually that is backed by some kind of machine learning. So yeah, so these are two categories, I guess, of attacks, and basically the reality is that the amount of attacks always always grows. There are always new attacks because there's always new code and there's always new features and new products being launched. That makes sense?
Yeah. So you mentioned this, the WAF, this web application framework, and trying to understand like what is questionable traffic. So if you're deploying, some new website, some new API, and it doesn't kind of know what to expect, how does it understand what is questionable and what is considered pretty normal traffic?
Right. So there's I guess like in every machine learning operation, there's the cold boot problem. So if you have something new, then obviously it hasn't yet learned enough traffic to tell you what's normal and what's not. But luckily, I guess if someone would look at most of the internet traffic, they'll realize there's like clusters of normal traffic and there's cluster of irregular traffic. And again, probably this is the secret recipe of every different vendor of such firewalls. But
Fair enough.
but the generic case is that there's there's normal behavior, and you have so much traffic these days, public traffic and so on, that you can analyze and build on. And there's like irregular traffic that is very specific to a certain service. And I can tell you from experience that yeah, definitely it takes time for these technologies to actually learn what is normal, and you get a small amount of false positives at the beginning. But the good news that is that if you have traffic, then it learns, and if you don't have traffic, then maybe this service is not that popular or risky, because you don't have traffic. So yeah, so in this specific case, it kind of creates a nice closure on it. So there's no gaps.
Nice. So I'm going to take a step back and come back to this in a second, and correct me if I could be completely wrong here. So if I'm thinking from the shoes of an individual developer like myself or Jason or anybody who's just developing software, and I'm going to assume, which you might have to help correct me. So if you're at a really big company, chances are you're not able to deploy straight to the cloud, or at least that's been my experience. Is they typically have it pretty locked down. There's like procedures and reviews to go through, and there's a whole organization kind of devoting to that. So if I flip to the other side, if you're a super super small, like only a single developer or a couple developers, then you probably are the whole entire stack. And then my guess is there's a sort of gradient in the middle where, like you kind of mentioned before, this shadow IT, where maybe there's people who are trying to do IT or monitor it, but they're not everywhere. You could get around them. And it's not that you intentionally or unintentionally meant to, it just sort of kind of happens. Where along the spectrum do you find that many of the developers kind of live in? Like, I'm not clear from my side. Like, I've spent most of my life working at relatively large companies where these kinds of things you're talking about have always been of interest, but have always kind of been handled by someone else or handled by the platform. So if you're building something yourself or in a company that's, let's say, sort of medium or small size, how do you sort of figure out like who the right people to contact are, or how do you kind of figure out for yourself what are the best development approaches to make sure that you aren't accidentally going to expose all your data to the world?
Right, right. So the thing is that, and that's why I kind of connected to kind of an evolution. So there used to be good news for this. There was used to be a good answer for your question, and the good answer would be, oh yeah, once you have a few controls in your organization, basically 90% of the problem of the risk is gone. But that's no longer the answer. For the big corporations, the I don't know, the Apples, Facebooks, Amazons. I believe it's so insanely sophisticated there that there's very little chances of a developer adding risk in terms of security, because the investment is probably huge. But for the medium size and the emerging companies that have to deliver and ship fast, which is probably the majority of the companies these days, there isn't this kind of resources. And also the times of one solution to rule them all is gone. So you can't really buy a system, put it in your network, and now all of your security issues are gone, because ways to do things are just growing. So just for example, if you look at your machine right now, I mean, ignoring where you currently work at, if you look at your machine and have a small thought, what's in your bash history, assuming you used your terminal? What's do you have a dot files? What's in your if you use Vim? What's in your vimrc? Do you have any secrets there, any tokens, anything that is maybe issued by a company or organization, but you have it right there? And guess what's the first thing hackers want to steal? Right?
Yes, logins and passwords.
Exactly. So, and don't tell me, but by all means, have a look after after this. Just do a less on your social history, and figure out what's in there. What's the material? How many times do you export a token? Maybe even an ephemeral token, something temporary, but still, it gives clues. It gives clues to how systems work, and you know how many of the tokens are temporary and how many of them are permanent, and how does one look like, and so on and so forth. So all these things are kind of happening on the last mile, which is us, the developers. So you can look at an organization and say, wow, that's a fully secure organization. But the last mile is probably us. We use all the, in terms of R&D, we use the assets, we connect them, we take on the risk of, yeah, I'm going to use this token and this password and this secret, and I'm going to connect this to this external service and to this external machine, and I'm going to store some stuff on my machines. And all these things combined are just, ways that I've adopted to be super productive. And as the world of software grows, the ways to be super productive also get more sophisticated, and that creates an impossible an impossible problem for one cyber or security solution to solve. It's basically you need to solve all of the habits of developers at once.
Yeah, I guess I don't. Security is not my background or my forte, but I always hear security and depth and layers of security, and I guess this is what you're sort of mentioning, like the last mile of developers. And we were talking at my company a little bit about social engineering, and just my takeaway was basically like if someone targets to social engineer you, you're kind of hosed. Like the amount of sophistication in some of the attacks that have been uncovered is just insane, that no matter what you do, that someone could probably figure out your username and password without you kind of knowing that you've turned it over. And I guess as you're mentioning, if you store stuff on your computer in your dot files or even just in your history, and they get access to your computer, they're going to learn a lot. And I guess that makes sense. That kind of brings to light to me the why you have to have so many layers of security. It's not just the firewall at the outside or the intrusion detection on the inside, but also like even on individual computers, like having people have good habits and stuff.
Right, right. And you can't not have your dot files, right? Because first of all, dot files indicate a kind of progression, right? Because you're using something that supports 12 factor apps and is considered as a best practice, right? But and there's like a huge warning here that I think we all miss, is that somewhere we should have a dot file that is not meant to be in a repo, but it's laying on our computers. And what's in these dot files, I don't know, but I'm quite sure that a hacker learning these best practices, they also want to learn how to abuse these best practices. So I don't know, I would build a script that searches for .env .production
Yeah, I think.
and grabbing it from your computer, right?
Oh, yeah, yeah, I think, I took I also, like Patrick, don't have a strong background in cybersecurity, but I did take a course on it in university. And I remember at one point someone was, the lecturer was talking about, the magnetic hard drives and how when you just erase something, it's not actually gone. It's just, some reference to the data is gone, but you can still recover it. And someone started kind of challenging and saying, well, if I do all of these things in this course, then I'm totally untraceable. I'm totally secure. And the professor had a really insightful answer that always stuck with me. He said, yes, he said, but if you're a criminal, and this was for like cyber forensics type stuff, if you're a criminal, you have to, make sure like in the world of atoms, you're totally, untraceable. And in the world of bits, you're untraceable. And you didn't leave any footprints and you didn't, and so when you start accumulating all of this, it becomes harder and harder and harder to get away with something. And so this is also true where there's so many different systems we work with. We use 10 different languages, and we're on 3 different public clouds, and there's 4 different machine types. When you start adding it all up, if you have a problem even once, that could be enough to get access to everything else.
Right. And that is, I think this is completely what's happening right now. And unfortunately, a lot of it is happening in our domain, like in the developer space, because the general sense is that if we get more power, and I can look at the Docker just as something that happened that gives us developers more power, because now I can, I know previously I could use VMs, but now I can, kind of juggle machines and plug and play them, and build so many things in a better way. So I have so much more power using Docker. And all these things kind of shift the power towards the developer and shift the responsibility also to the developer. And the big question is, uh, did we know that that happened, that we have more responsibility now? Because as far as we care, we have more stuff to play with. I mean, I'm super productive. I'm much more productive than 10 years ago. But did I know that I now have much more responsibilities in terms of security? So yeah, so I think that the answer for that is that we're seeing that not everyone realizes that, with that extra oomph that we got with all these technologies that we actually have now, we are taking more risk as developers. So that is the friction that we see. And the answer is to try to use the same tools that we use to build features and products, and to figure out what do we miss. So I just said, yeah, if I'm a hacker, let me just build a scanner that tries to find your .env .production, right? So how about we use that and build a developer tool that actually can tell me that before the hacker knows it. So here's you go. Here's an idea. Build a tool that scans for all these kind of these files that that you have in the back of your head on your computer, and that is a tool that you build for yourself and put it in your own toolbox. And now you feel much more secure, and now you can work in a safer way. It's like a carpenter working with security goggles, right? So this is how you can actually build the tools for yourself, so that you can actually take on more responsibility. So that was basically my thinking, I guess, throughout all of my career. So that every step you need to actually make your toolbox bigger, so that you can actually take on more responsibility.
Yeah, so when you talk about, like, I guess you're throughout your career you're saying, thinking about this toolbox. I guess it's probably bad, but I'll admit it. Like, I don't really spend much of my day thinking about what tools could I add to my toolbox to help make sure that I don't leak secrets. I'm a bad engineer, I guess. But how does someone go from the mindset of, like, my job is to sit here and, as you were mentioning, faster and faster to ship a product, to see what sticks. So what is the phrase? To move fast and break things, right? I didn't invent that. And, like, how do you go from that mindset to sort of culturing a sense of, like, hey, wait a second, I'm taking these risks, and they're really easy to not take these risks. These are the common dot files that people would scan for. I mean, it makes sense when you told it to me. It seems obvious, but I won't admit that I probably ever thought about it before. How does someone go from my sitting here and just developing code to, I also need to have tools in my toolbox for not just developing my code, but for making sure my code is safe and secure?
Yeah, so actually it can be very simple. I mean, to me, it's very clear, and I'll try to give the same clarity in how I think about it. So I remember the day when we used to ship software and zero tests. That was around 2005, 6 maybe. Yeah, no such thing as unit test. No one even knew about that. And basically, you would ship your software. You wouldn't even test it, properly, and you'll figure out, yeah, we have a QA somewhere down the line. They'll do the work, tell me what's wrong, and I'll just wake up and fix the stuff they found. That was life. So, and that was not long ago in terms of, in normal professions, like 15 years in, I don't know, in car making, that's nothing, right? So that's 15 years in software. So that was the reality. But since then, in terms of quality and QA, I mean, we almost obliterated that kind of workflow, and we have unit tests, end-to-end tests, and so on and so forth. And everyone knows that you need to have coverage. So that's one thing to think about. Another thing to think about is distributed systems, right? So there was a time where we built, a server, a server, a service, doesn't matter, and we deployed it to one single server. And that again was at the same kind of area of years. And maybe we used two. That was like amazing, and the load balancer was kind of a hardware thing that you know, you had to put out from a box and install it somewhere. And we never thought about redundancy in the way that we do today. And today it's insanely more involved and so much better. And again, today, what we do is we plan a service, and almost before the first line of code, we think about how is it going to be deployed, in how many instances, and how would it fail, and so on and so forth. And I think security will go through the same evolution. What changed? The only thing that changed is the responsibility. So on the QA story, there was a group of people who were responsible to test your code, but not you as a developer. And on the on the redundancy side, there was the group of people called IT, not even ops, and they were supposed to make sure your service is always live, which is absurd these days, because how would they even know back then? And today, you guys just said it. In some organizations, you build your code, and there's a bunch of people who are responsible to make sure you don't do a mistake or don't put the company in risk. So, just from a history point of view, the story should repeat itself, right?
Yeah, I mean, I think as you mentioned, like a single developer becoming more and more. I mean, in the beginning there was only the developer, and then there was the organization, and then now we're going back to only the developer. So yeah, I would say it's a fair bet to say that it's going to go back to a combination of people, and we'll see if it. I sometimes think that the roles can be embedded within the team. So, we talk about like deploying on Docker or whatever. Like, it's not that you have an ops team that is responsible for deploying everything, but maybe you have, a person or a consultant on your team who helps you do it. And it's still the team's responsibility, but there's someone there to help it. So I guess if I hear what you're saying about security, thinking similarly, like having someone who isn't there to just, send you emails when you've accidentally leaked your password, but actually, help you guys develop good practices and sort of look over what you're doing and make good suggestions, and is a shared goal with your team. Yeah, I think that can make a lot of sense.
Yeah, and you ask how can actually teams can improve, and take more of that ownership over security. So that's the first step, realization. History repeats itself, and I'm a huge fan of philosophy. And what I see here is a pattern that repeats, and I'm quite convinced it will repeat itself, because we're all people and humans, and we collaborate and work in fairly the same way. What's the difference between quality and quality of service, which is actually kind of what distributed systems come to solve, and then quality of your security. So it's all the same. So that's one part, and the other part that I believe in personally is trying to instill the mentality of retrospectives and learning from mistakes. So if you have these kind of processes in your company, in your culture, then you can always use these processes to actually have plug in a space for, hey, we're doing a pre-mortem or a post-mortem. Let's talk about how security is in this whole picture. So we talked about redundancy and deployment, and how's the capacity planning. How about we talk a little bit about security, which means sometimes you can either simulate attacks, sometimes you can either prove that a certain service is secure, or sometimes you can just list what your what your risks are, and that is a great conversation opener. So if you have a billing service, um, then you can actually state your fears, and you can just say in that same form, your fear is that someone can go in and I don't know, steal what, credit cards, transaction numbers, and so on. So just by stating what's valuable for you in that same form of pre-mortem, retrospective, whatever, you can actually start a great conversation, and you can discover that people didn't even realize that the service you're building is actually holding a lot of value for a potential attacker, and that is 50% of the job.
Yeah, you're kind of describing now. We've kind of covered a lot of ground already, but you're describing now. You were mentioning sort of thinking about the attack vectors and what is the where could people attack? What would they think about a value? Sort of thinking about coming from someone on the outside, not just, hey, I'm playing with your service, but I'm looking at it, I'm analyzing what I could get from it, and then I'm deciding how much time to spend, whether it's just to crash your site or to drop your data, or if there's something here I could extract. And I guess that even of itself is a useful way to think about it is I'm deploying this service, which is valuable to end users, but in some ways, like the more personal data or credit card, whatever those things that might be most valuable to delivering really awesome experiences to end users would also be very juicy targets for attackers. And I
Right.
guess the juicier the target, the more concerned you have to be with making sure your stuff is very secure.
Right. And always I try to keep it very, very simple. There's, you know, think about what you're doing in a day to day. Is your computer filled with sensitive material? Did you encrypt your drive? Because once in the times when we used to go to conferences, then I literally saw. I won't name the company, but it's a big cloud company. Two solution architects just leaving their laptop on the chair and going for the restroom, and I was kind of looking at two laptops with obviously the company sticker on them, just telling me steal me, right? I mean, so once that happens, if you didn't encrypt your hard drive, basically it's just 5 minutes and I have all of your data. So these are the small, simple stuff that I like to think. These are the terms that I like to think in. So it's very, very simple. It's connect to the stuff that you're doing on a day-to-day basis that you're feeling uncomfortable with, and try to figure out what that is. And on the other side is also, in terms of organization and teams, it's also very very simple, is connect to the things that you're fearing from, like your fears. So basically when you're about to deploy a service, I'm sure as hell, like as a developer, your fear is that this service is going down, right? So you'll try to figure out how to keep it alive, and avoid waking up at night because you didn't I don't know, throttle something properly, or you didn't think of an edge case. So just add another layer of fear, which is I think this service is storing sensitive data, and I want to just state that. And that is just a simple way to start a conversation with other intelligence people, and brainstorm and think what you can do. And obviously when you do that a few times, you'll probably get to a more advanced levels of thinking of attack vectors, and kind of instilling this culture, and it'll just happen from itself.
Yeah, I think you're right. I think realizing it's an issue, thinking about it, these things are, important. I feel like it's, like you said, from philosophy, applies over and over again, not just that things repeat itself, but that kind of the path to learning about it is first realizing there is something to learn. And I think the topics we're discussing here are interesting approaches. So we've talked about on a developer computer that having something that scans for maybe secrets that you wouldn't want pushed out or that you wouldn't want someone to get on your computer. We talked about application firewalls and traditional firewalls. We talked about a little about SQL injection. So we talked about a little bit like someone getting on your computer or stealing your computer hard drive. We talked a little bit about like the end deployed app. What are other areas? I mean, there's a whole pipeline there, I guess, of, you know, not just developing the code, but then pushing the code, serving the code, you know, like the distributed systems themselves. Like, what are other areas that are important to think about security in?
Yeah, so there's two niche areas, I would say. I would be careful with calling these niche, but there's a reason I didn't mention these first. So one is the uh, I believe maybe the scariest of all, which
Uh-oh.
is getting an email, clicking on something, and then bam, your computer is now locked with all the data, and you need to pay someone millions of dollars, right? So this is like the whole ransomware thing, and yeah, as you mentioned, the best way to combat this is to actually be aware. So have awareness training, and make sure you know what phishing is, and sometimes email specifically, sometimes in terms of emails, there's some email providers that are very advanced that can tell you, listen, this email came from outside of your organization,
Hmm.
and I'm a fan of Gmail in that sense. They can color the out of your contacts thing. I don't know if that exists in other clients. I hope it is, but this is a good part of awareness that I thought should be there, and it wasn't there for a long while. I mean, if you're an email client and you're working in, you're giving a service to an enterprise, and obviously you can identify who's in the organization, who's outside, and then just give me a color, tell me, listen, someone from outside the organization is now sending you an email. That's a great thing to know.
And flagging hyperlinks that don't match the URL they point to is another one that shocks me that email clients don't do today.
Right. And obviously all the DNS typos, which is fun. You have a company name and then someone changes a letter, maybe turns an I into a capital I, which looks like an L. And then you have something which looks familiar but isn't. So that also, that is also something. I don't know if to call it funny, but it's when you realize that you can do it, and you go and buy the domain for like $4, and then and then you have something in your hand that someone can use for attacking. So basically, by the way, this is something I do in almost every company I join. I look at the domain and then I go and buy all the similar looking domains and hand them over to the ops and IT people to just have these domains, just buy them so no one else can buy them, and it's very cheap. So I really encourage everyone to do that for their companies. So yeah, so this is one category which I would call niche of kind of attacks, because they're very specific. And the other one is actually that would feel nice to people who works with embedded systems, maybe more, because in there there's a category of languages which are considered unsafe. I guess that's a category of languages that was kind of born these days. But the
You're about to
idea,
attack me, aren't you?
no. And the idea is that I mean, to me, it's strange because I remember programming in C and C++ like it was yesterday, and also assembly. I'm from this generation.
It's today for
So,
me. So
and these days, these languages are kind of portrayed as unsafe, and basically because they are not providing the right checks for your memory usage out of the box by default. So this class of languages, you have a whole, I don't know, domain of proper usage, so you could actually build secure software. But it is secure in the sense that when you, I don't know, when you put the software on a pacemaker, then no hacker can actually hack that, I guess, or a spaceship or whatever. So yeah, so there's this whole domain of security geared towards making sure these things are as safe as possible. And just to look at this from a developer point of view, then when you build this kind of software, so one of the most accessible tools to use is a fuzzer, which basically means it's a kind of a tool or a library that you can use. It's I try to explain it in a simple term. If you have a function that is supposed to receive a string and an integer, for example, then this tool would look at this function, analyze it, and try to inject kind of brute force all of the strings in the world, like huge strings, strings with binary characters in them, strings with Unicode characters in them, and we'll do it by brute forcing. It won't try to be smart about it. And if it's an integer, obviously it will try to overflow it or give it some bad numbers. And basically, it takes some time, and then it will come up with a combination which is bad for your software. So basically, you'll be fuzzing this for weeks and weeks and weeks, and then you'll be able to see if there's any result, and this result would be gold for you because you just exchange time with something which is very sensitive. If this, for example, if this was a spaceship, right? So that is a whole category of security and very geared towards the developer, and also in the realm of embedded or things that are in that sense are can become very, very costly.
Just to riff on that for a second, for people who may not realize, so if you run a fuzzer and your program crashes, there's a number of different reasons why it could be a problem. So the first reason is that obviously, like if you were running a spacecraft or a service, if it crashes, it's down, and then you have an outage, right? And so someone could keep sending malformed data and crashing your system. And if they do that enough, then you have a sort of denial of service problem, or even worse. And so in that way, that's kind of like the first class of problem. The second class of problem, though, is that sometimes it crashes because you're not checking the data properly. And the crash can actually lead to a buffer overflow that allows someone to exploit your code and then actually read contents of your computer or your memory, and actually steal results, which is much worse than just crashing it. And so running a fuzzer and finding those things is super useful, because many times it's unobvious, especially if you depend on another library for doing something like JSON parsing or your any kind of data consumption, and someone can feed in there. And if there's a problem in that library, which you used because you liked the fact that it had a lot of convenient functions in it, you could be opening yourself to a whole host of problems that you didn't realize.
Right, you just said it much better than me. But yeah, you can claim, I don't know, maybe as we have SpaceX and all these, maybe there's many more developers that are being called and shipping into a spacecraft these days than there was when there was only NASA. So I don't know. Maybe fuzzers will come into fashion.
Yeah, so we talked about, okay, a couple other niche areas, and then one of the other things I know people kind of mention is, you see every so often, is someone will publish a report where they scanned GitHub and they found 10,392 places where someone had their database password stored. What are the So obviously, like, that's a huge problem. Like, is that something that you see people doing, is pushing code itself up to a repository where they've put something in there
Yeah,
unintentionally?
yeah. I mean, first of all, quick disclaimer: this is part of what we do at Spectral.
Oh,
Eh,
okay. Well, I guess I teed one up for you then.
yeah, and by the way, just to close a small circle, which it's so much fun to recommend when I can recommend it. So I've been through, I don't know, since assembly, probably through almost every programming language, including Haskell and Erlang and some wacky languages. And at Spectral, we use Rust, which on the fuzzing unsafe languages part of things is supposed to be safe, and as far as I can tell, it is. And And there hasn't been a morning where I need to wake up and look at the code and say, this is an amazing programming language that gives, it gives me the holy grail. So just to encourage people to just try out Rust. It's an amazing language that is, for me, it's as performant as C++ and as expressive with none of the disadvantages. It's amazing. And back to your question. So yeah, so people do tend to do these mistakes. And I mean, it's actually a reflection of the situation right now, which is there's so many tools, so many technologies, so much is being asked from a developer these days, that there's so much opportunity to make a mistake. And making a mistake is let me give you an example. Is using an IDE that you think let's use a concrete example. So you have IntelliJ, and IntelliJ likes to save some settings in a folder called .idea. And as far as I can tell, and anyone else can tell, this folder is clean. It's safe. So if you like, you can actually push it to your GitHub repo, which is public and everything is great, because you get a guarantee the common sense thing to do from IntelliJ's point of view is make sure it's clean and let you publish your settings so that if someone else takes the project, then they will get a nicely configured environment for them in their own IntelliJ editor. So that's the understanding that almost every developer has. But here's the twist: there's also plugins. And some developers would choose to install various plugins, unofficial ones. And I've seen in my own eyes a plugin that is actually doing something more than a search, like some hyper search something. And basically, I've seen a project where a developer pushed their own private settings. And in there, they had this plugin installed. And what this plugin did is break the invariant that I guess IntelliJ has, that this folder has to be clean. So basically, the plugin saved and cached the search terms of the developers inside this folder.
Oh no.
And it's a little bit funny because you could see how the developer cleaned up the project before publishing it. So you would see the searches right there in a public repo. You would see Amazon, and then AWS, and then EC2, and then you'll see the actual Amazon key and secret. So basically, what I've watched is the entire history of the developer trying to clean up the project before publishing it, and they search for the actual secrets in order to remove them from the code. But the plugin
Oh, they were trying.
exactly, the plugin recorded everything and dropped it inside this .idea folder, which is supposed to be clean. That is the understanding that every developer has. So they pushed the project, published it, and basically because it's a dot file, I guess they're always, they were all also on Windows, and by default on Windows you don't see hidden files or whatever. Yeah, completely didn't know about it. It was sitting there for at least 6 months until we reported it to the company that we saw this exposing. And yeah, the story that we got after that was basically, they had miners and breaking into the cloud and whatever. So it was a mess for them.
Oh.
So this is just one small example of so much. There's so much freedom, so much technology, so much to use and to experiment with. But you don't always get the best offering. Basically, this one was down to adopting some plugin which looks cool, but I guess the developer of the plugin didn't have security first, or didn't really understand or realize that there's this kind of agreement that this folder needs to be clean.
Yeah. Well, I guess that serves as a pretty good transition as we sort of wrap up here for you to talk a little bit about what Spectral is and sort of what it does.
Yeah, so Spectral is a tool for developers. It's a security scanner, and it tries to do kind of things that we talk about today, which is follow the habits of a developer and be the best buddy, and make sure that everyone can use it for themselves, and make sure they scan their work and scan their computer, and make sure they don't do mistakes. And we say mistakes because that is what it is. It's, you can say vulnerability, that's a different term, but basically at Spectral, we're 50% coming from cyber and 50% pure engineers. So we like to keep this balance of productivity and security. So we just call it, mistakes. I think that is what it is. And a mistake is something that was made on good intention. And basically, a whole class of mistakes is, using and misplacing sensitive data, secrets, passwords, credentials, and so on, and placing different files somewhere you don't want them to be, and realizing we as a company are trying to realize the habits and the workflows of a developer, and making sure there's always a great solution for that. So I think this week or next week we're going to release an open source product. We're going to open source it, and what it does is, I don't want to jump the gun, but what it does is acknowledge that the whole usage of vaults or dot files is not perfect. So it acknowledges it and gives you instead a nice tool, which is open source, and you can build it and do whatever you want with it, which gives you a clean way to actually handle secrets, grab secrets from a vault, or grab it from your disk, or from any other service, and leave zero footprint on your hard drive. So basically, everything is in memory. So this is something that we identify that developers are struggling with. So yeah, so this is just another example of something we do, and we will launch next week.
Oh, nice. I'll have to keep an eye out for that. And then what about Spectral as a company? So you said you're 50% sort of cyber, 50% engineers. Are you guys looking for interns? Are you hiring? What is it like to work at
Oh
Spectral?
yeah, so first of all, we're hiring. Basically, we have kind of positions for Rust engineers and Go engineers and Node.js. Um, and I guess you could say we are always hiring. I mean, we're always willing to meet great people. And in terms of the company, it's the COVID thing kind of caused us to be fully remote. But lucky enough, we're kind of, in terms of the experience in the company, then some of us come from distributed companies by definition. So uh, we were able to create a really great infrastructure for being a nice remote first or distributed company. And yeah, so we're being super productive, uh, making sure we have all of the advantages of distributed, and zero of the disadvantages. And yeah.
Nice. Nice. So do you guys think you'll, I mean, you don't have to answer, but do you think you will stay virtual, or you guys think you'll go back to a somewhat normal thing when this is all over?
So yeah, so we basically try to always think about the balance and think about the people first. So there's first of all, it's finding the right tools. So is Slack the right tool? Is email
Mm-hmm.
the right tools? Right. So what we found is we use Discord, and that was on a simple thesis, where if gamers are really liking that platform, that coders probably would. And we found that it actually proved itself, because when you share your screen and share multiple screens, and people can watch everyone else's screens, and I'm what I mean is editors, right, writing code, and not games. So you have zero latency, and you have really great audio, and everything just works. So you realize that this whole thing was optimized for sharing games, and it's more than enough for sharing code and doing pair programming, all these things. And you also have rooms, we actually made a few rooms, just a few, not too many, just like in a real office. So we have rooms that everyone wants but are taken, right? The same frustrations. So basically, our Discord resembles a real office. You can just drop in a room, drop into a conversation, and it's really, really fun. So that is one thing we realized and experimented with, and really works well for us. But yeah, we're trying to create a balance, and also when possible, meet physically. But yeah, we're always thinking about this as a problem. How do we solve it? Kind of like engineers, like an engineering problem.
Nice. This is a great heuristic that if gamers like it, engineers might too. Yeah, I think that's a great takeaway.
Yeah, it's great.
And then, what about you personally? You have are you on social media? Do you have any? I think you might be doing some other stuff. Anything you want to share with people?
Oh yeah, so I'm on GitHub, Medium, and Twitter. I'm John Dot, JONDOT. And yeah, I kind of I'm trying to be on everything at the same time. It doesn't work, so I'm dividing my energy. So you'll see me active, periods of times on GitHub and periods of times on Twitter. So I just load balance. I can't do everything in parallel. So yeah.
All right, very cool. Well, thank you for your time, Dotan. We really appreciate it. It was a really awesome high-level overview of security. I had a good time. Thank you for coming on to the show.
Perfect. Me too.
Music by Eric Farndollar.
Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix and adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.